As we move into topic 1 of chapter 2, for those of you who have had the 1103, we're going to be doing a little bit of review of graphs, so something to remember. And we see a little graph here. Remember, a graph is made up of two number lines, one horizontal and one vertical, that divides the plane into 4 quadrants. Quadrant 1, 2, 3, and 4. And we use the reference Cartesian coordinate system, in which we have ordered pairs, as you see here. And the way they're often written, we have an x value, comma, y value. So if we were to plot any point, for instance this 3, 2, we start at the origin, which is 0, 0, and then we go in a positive direction on our x-axis first to 3, 1, 2, 3, and then we go up positive direction to 2, and that gives us this ordered pair. Now, there were some background formula that you should be familiar with in this course, and one of them, and we're going to call this equation number 2, when it's in this form, this is y equals mx plus b, where m is the slope of this line and b is our y-intercept. Now, we're going to see basically two types of equations. This one, since our values of the x and the y are to the first power, this is linear. And then later we're going to see another one which we haven't identified before, although this part looks very familiar. And if this were a 0, this would be the standard form of the quadratic equation. But written this way, it actually defines a parabola. And we'll be getting on to that. Let's look at example 1. Which of the following are solutions of this equation? So for things like this, starting off not too difficult material, we substitute the 2 and the negative 1. So our y is a negative 1. Our 2 is the value for x, so that would be negative 2 times 2 plus 3. So this is a negative 1. This is a negative 4 plus 3 is a negative 1. So this ordered pair, we know, is a solution for this equation. And we do the same thing for letter B. Let's clear it up. We put the 4 for the x value, and I guess it's right there. And I guess they're using the same equation as up here. So if we say y, which is 7, negative 2 times 4 plus 3, does that equal 7? And this is 7, this is negative 8, negative 5, so no, this one does not. It's not a solution. Now for example 2, they're introducing the use of a t-chart where we have the x, and in a sense this will be our y value once we put that x into this formula, because this represents what y is, and we get various points. And interestingly, you'll note that all of these points are in a straight line. So if we take our line tool, we actually create the graph of this equation. Now we might ask, how many points are there along this line? Well, we did a few of them, and we know that there's actually an infinite number of points along this line. We used a representation of sum to give us enough to make a line. Now, keep in mind there are different ways to graph. Making a t-chart was one, and we also use the idea of if we plot our y-intercept, which was a 0, 5 right there, and our slope is a -2 over 1, that is, we move to the left 1, which is our run, since this is negative, and then up 2, or we could have gone up 2 and then over 1. Either way. And we could go over 2, down 1, there's another point, over 1, down 2, there's another point, over 2, down 1, another point. So again, we can do a number of things using this particular formula. T-chart, and then using the formula to directly graph. And we'll be doing some more of that shortly. Now, one other thing before we leave this, as we said that this is our b value, y equals mx plus b. And we said b was our y-intercept right there. And then there's our x-intercept. Now, we didn't have a point for that, but they are illustrating it right there. And if we look at it, it's 1, 2, it's actually 2.5, comma 0 would be our y-intercept. So if we put a 0 in this column, what we would get in this column is 5 halves actually, which is 2.5. Okay, a couple of things. And in here they are describing the x-intercept, that if you put y as a 0 and you solve for x, it was 5 over 2. And we've already mentioned the y-intercept, which is our b value there. Okay, now we can also, when we look at these quadratic equations, find our x and y-intercept. And they're asking us to do it of this particular equation. So let's make a little t-chart. Now, if we have a straight line, we can usually just put a 0 here, and then whatever value we get there would be our b value, and a 0 in the y column, this would be our a value. But actually, when we deal with quadratic equations, you recall from recent studies, we got 2 values. We're going to get 2 values where it crosses the x-axis. So with that in mind, let's take a look. So we're saying that x is going to be 0. So into our basic equation, we're going to put a 0 where the x's are. So this is 0 here. This is going to be 0. So we have y equals a -8. And we said the form for our y-intercept was 0, comma b, or in this case, 0, comma -8. And we'll show you that. Now, to find what our X-intercepts are, we will then put this equation, instead of having a y there, we're going to say our y is a 0. And if we factor that from a previous lesson, equal each of these factors to 0, we get x equals -2 for one value, and x equals 4. Remember that statement, finding the zeros. That's what we have here. So if we were to make a graph of this, this parabola is going to go through our y-axis at -8. So 1, 2, 3, 4, 5, 6, 7, 8, right there. And it's going to go through our x-axis at -2, right there, and at a +4. 1, 2, 3, 4. So you're getting a little bit about where it's going to go through. And that's what it will look like. And we'll show you this because we do want to find where the tip of our parabola goes. And we use the word vertex to describe that little tip there. So far, we have found these that I've underlined. This is one of your X-intercepts. This is the other X-intercept. And this was our Y-intercept. So there, and there. Now, we would have needed a value of y is a -9 right there. And then our x value of 1 in this particular equation to see where our vertex is. And we'll be coming back to address that. But while we're here, just to do a little light review of what will be in the future, we're going to say that as we look at this parabola, if you were to take a line, I'll take my line tool and put it right here through the vertex. Notice the parabola on one side is the reflection of the parabola on the other side. And the equation of this line that I have just added is a vertical line going through point 1 as x equals 1, is what we call our axis of symmetry. And once again, our low point here, this was the vertex. And again, we're just anticipating things we'll be doing a little later as we move on. We wanted to get an idea of what a parabola, a quadratic equation, its graph is like. And here we have found the zeros. When y is 0 right there, these are our zeros. A -2, a -2, and a 4. That we also solved by using the quadratic equation, factoring it and getting those values. Okay. And looking at example 4 now, they're asking us to sketch the graph of this. So here we have a radical, and y equals something. Well, remember, you cannot have a negative value under this. So this has to be, when we go to solve it, greater or equal to 0. So these are the points we're going to put, and they will give us a suggested t-chart on our next slide so we can see what it looks like. So there it is. We've developed some points. So it is going to be sort of a curve. And the key to it, when we see under the radical sign, there is a positive 2 there. When we do that, this takes our graph over to actually a negative 2 as our first point. When when y is 0, x is a negative 2, this point right here. So that's our first point. And then we get when x is 0, we get the square root of 2, which is right there, approximately 1.414. And then when x is 2, 2 plus 2 is 4, the square root of 4 is 2. And I've just put some other points in there, and it gets to look like this. Now, as a little aside, suppose we had this equation, y equals the square root of x. Well, without the positive 2, an interesting thing would happen here. This would start then actually at 0, and then it would shift this whole graph over by, this would be here, and this would be like so. And again, just a little background, y equals the square root of x minus 2 under the radical sign. This one would start actually here. So if it's positive, it switches it over there. If it's negative, there's a shift to the right, opposite sign. Just some interesting things that we'll be looking, but the shape of the graph for the square root of x generally is this shape. Depending what you find under the radical sign, we'll shift it one way or another. If it's positive, it shifts it to the left. If it's negative, it shifts it to the right. Now, when we're talking about solutions of an equation, that if there's just x equals something, you're going to have a single point on a graph. And y equals something, again, a point. And here we're talking about the intercepts. I think we've gone over that. Now let's do a little bit of background on graph reading. So in example 5, they're talking about in a newspaper, let's say, they give you a graph of the day and what the stock market was doing, the S&P 500s. So let's take a look at that and what they're going to ask. What was the value of the S&P 500 index on day 11? So we would look at day 11 right there, and we go up and we have a dot right there. Then we go to the right and we pick that out. And later on day 17, day 17 would be right there. We go up and then over, it's this. So I think this is something easy, and these points seem to be right on the grid, so we didn't have to guesstimate what was going on here. And for B, on what days was the value of the index above 1,425. So for this, we'd have to go back. And then 1,425, which is right there. So we'd see it's day 7, day 8, 11, 12, 13, 14, 15, 16, and then it looks like 20. And there we see it. Okay, let's go on to example 6 now. Business. Monthly revenue and costs for the Webster Cell Phone Company are determined by the number T of phones produced and sold as is indicated in the figure. How many phones should be produced each month if the company is to make a profit, assuming that all phones produced are sold? So let's take a look at that. Looking at our lines here, the red line is revenue, the blue line is cost, and these are the number of cell phones in the thousands, and this is money in the millions here. Okay. Well, what they're saying is, if we look at about this point, where revenue, the red line, is above the blue line, that's where you make profit. And then over here, as long as the red line is above the blue line, that would be the profit area. So they're suggesting 12,000, which is about there, because each of these lines are 4, and 48,000, which is right about there. That is your profit range. Now they do give reasons here, which I'll not go into, but you could read it. Now in part B, is it more profitable to make 40,000 or 44,000 phones? So again, we look at our graph, and at 40,000, we see this much of a difference, and at 44,000, we see this much of a difference. So notice there are 3 grid lines at the 40,000 and only 2 grid lines. So it's definitely more profitable. And what they're suggesting too is you could use the coordinates of these points and do some subtraction. And you can see that here there's a greater amount of profit at 40,000, less profit at 44,000. Again, for some reason, as you start producing more over here, your costs go up. And they suggest maybe it's overtime and manufacturing costs increase if they produce that many phones. Again, we're not looking at that particularly, but as a suggestion. Now, for example 7, we're talking about technology in graphs, where there are graphing softwares available, and we put this data into our graph, and we talk about the viewing window on our graph. There is a range and plot setup where they give you the parameters of what to do. And for TI-84s, and if you have one, or the graphing software that we may be using, this is what you would follow. And these are the windows putting the data in. And going through this, you get to see what this graph, which is to the third power, actually looks like. And you can increase your window parameters to spread it out to see things more clearly. And notice if we're looking for the zeros, we'd have one there, and one there. And in example 8, use a graphical root finder to find these. Again, there are 3 solutions where your graph will cross the x-axis. These are finding the zeros. And example 9 is something similar. And again, depending on what we're going to be using as a graphing tool. And now for your practice and quiz me's as you work some of these. Again, much of what we had here, we had previously, except for the quadratics and the radical graphing.